All right. Let f be defined as this. Which of the following statements is true? Okay. So the issue here is that what this absolute value is going to do is it's going to let you have an input. So normally, right, this thing would have, if you didn't have the absolute value, right, this thing has a domain restriction where x minus 2 has to be greater than or equal to 0. So x is greater than or equal to 2. So normally you have this, right? This is what that would look like. But when you put this absolute value in here, sorry, didn't mean to cover that up. When you put that absolute value in here, what you're doing is you're saying, oh, hey, it can do this on this side too. Because the other side, because for instance, just however the number 3 would have behaved, right? Because if you plugged a 3 in, you would have gotten 3 minus 2, which is a 1. Well, 1 is going to behave the same way because 1 minus 2 is also going to give you a 1 now with the absolute value. So this sort of ends up looking like a weird seagull shape, right? If you understand that's what this graph looks like, you can pick the answer pretty quickly. It is continuous, right? Continuous, I'm not lifting my pen, but not differentiable because of that cusp. And if you understand it, you can pick A pretty quickly. It's much harder to do it any other way. You can definitely cross off vertical asymptote because there's no denominator, right? So there's no denominator, and that's what you need for a vertical asymptote, right? You can pretty much cross off, I'm going to argue that you can pretty much cross off the limit argument by plugging in a couple values if you're not sure about it, right? You could cross off the limit argument by saying, hey, what happens if I pick a couple values around 2 just to experiment? And what you're going to find is if you pick a couple of values around 2, it's going to become pretty clear that you're approaching that you're going to approach 0, right? And you can kind of figure that out. Again, that's not a perfect solution, but you can kind of troubleshoot and figure that out. This would be a root 2, and this would be a root 1, and this would be a root 1, and this would be a root 2. So if you pick a couple values, you can sort of start to get the image of what's happening. But realistically, this one's a lot easier if you can picture the graph. There's not a really great way to fall back on algebra to do this one. It's much easier if you can picture the graph.